Okay, so in this video, let's see which statistical test to be applied when. So broadly, we can classify the statistical tests into two, that is descriptive and analytical or inferential. When we come to the descriptive data analysis or descriptive statistical tests, we have two types of data. One is categorical data and another is continuous data. If the data is categorical, we will use frequency and percentages. And in the case where data is continuous, first we'll do the normality testing. And if the data is normally distributed, we will use mean and standard deviation. And if the data is not normally distributed, we'll use median and IQR. In the subsequent video, we'll learn in detail about all this. This is just I'm giving gist of which statistical test to be used when. Now coming to the inferential data analysis. So here we have three options, like major three options which we'll have in our data sets. One is when we are comparing categorical data with categorical data. Another option is when we are comparing categorical data with continuous data. And the third option will be when we are comparing continuous data with continuous data. So when we are comparing categorical data with a categorical outcome, like categorical input variable, independent variable, and a categorical outcome variable. In that case, we'll use chi-square test or Fisher's exact test or chi-square continuity correction or chi-square test of two proportion. Now, when we have categorical versus continuous, where the dependent variable is a continuous and independent variable is categorical. In that case, we will use independent t-test, paired t-test, ANOVA or repeated measures ANOVA. And when we have a continuous versus continuous, like independent and outcome, when both the variables are continuous, we'll use correlation matrix. Now, just to give a brief overview, if we have categorical independent variable and a categorical outcome variable, so we go and we check about the expected count. If expected count is more than 5 in 80% of the cells, we'll use chi-square test. If the expected count is less than 5 in more than 20% of the cells, we'll use Fisher's exact test. In the same way, instead of 2 by 2 table, if we have n by n table, that is 3 by 2 or 4 by 2 or 4 by 3 tables, then we'll use chi-square continuity correction. Then coming to categorical versus continuous, with two categories which are unpaired, like independent observations. In this case, we'll use independent t-test and the non-parametric counterpart for that is Mann-Whitney test. When we have two categories with paired data, like pre and post data, we'll use paired t-test and the non-parametric counterpart for that is Wilcoxon rank test. When we have more than two groups, we'll use ANOVA and the non-parametric counterpart is Kruskal-Wallis test. And when we have more than two groups with repeated measurements, in that case we'll use repeated measures ANOVA. So we'll go into depth of each and every test in the subsequent videos. This is just a gist about when which statistical test to be used at what time. Now the third option which we had is continuous versus continuous, where the independent variable was also continuous and the outcome variable was also continuous. So in this case, we'll use correlation. If the data is normally distributed, we'll use Pearson's correlation or Pearson's R. If the data is not normally distributed, we'll use Spearman's correlation or Spearman's R. And if we have ordinal data, like the data in order, let's say Payne score, so in that case, we'll use Kendall-Stau. So let's take one example for each. Like in descriptive, the categorical data will be like number of males and females or males and females in a data set. Let's say I have 100 patients data, 40 are males and 60 are female. So in that 40% will be male and 60% will be female. So we'll give this in the form of frequency and percentage. Continuous data is like, let's say a height or weight, where we have continuous observations. So in that case, if the data is normally distributed, we'll use mean and standard deviation, and we can say that the mean weight of the data set is this with standard deviation of this much. And if the data is not normally distributed, we'll use median and IQR. In case of categorical versus categorical data, let's say we want to see the outcome variable as diabetes status, whether the diabetes will happen, yes or no, and the independent variable as gender, male and female. Now here we can see the independent variable, which is gender, is also a categorical variable, and the outcome, that is diabetes status, where yes or no is also a categorical variable. Now let's see about categorical versus continuous. Let's say I want to see how much the weight will change, where weight will become a dependent variable based on the gender. I want to see how gender affects weight, where the independent variable will be gender, that is male and female, and the outcome variable is weight. So continuous. In this case, we'll use t-test. If let's say the observation was paired, I'm saying on a single person, pre and post, that time I would have used paired t-test. And if the independent variable, which was categorical, if it has more than two categories, we'll use ANOVA or repeated measures ANOVA. Now continuous versus continuous. Let's say I want to check how much height will change or how much height is correlated with the weight. So here we can see both independent variable. Let's say here independent variable was weight, and we are seeing how much it is correlated with the height. So in this case, both independent and dependent, both the variables are continuous. So in this in such kind of scenarios, we'll use correlation matrix. Thank you. In the next videos, we'll go deeper into each and every statistical test, which with real world examples and hands-on on the hands-on session on the Jamovi. Thank you.